Okay, so next part in our partial fractions, we're looking at repeated linear factor. So, first of all, what is that? Well, repeated linear factor in the denominator produces 2 or sometimes more, and we'll cover some of those later, terms in the partial fractions. So what do we mean by that? So first thing we are going to think about is we're going to just try and do one off the easiest way. So 6x squared minus 6 all over x minus 2, 2x minus 1 squared. Okay, and what we should be noticing is different in this one is that now in our bracket on the bottom, this bracket is squared. Okay, and so we are going to try and split it up into its partial fractions. So just like before, we're going to have a over x minus 2 plus b over, and this is where we need to kind of account for anything, because when we brought it together and simplified it, we don't know what might have gotten lost in the process. And so whenever we've got any of the brackets with a power, we have to include all of the powers smaller than that as well. Okay, so what we also need to do is, as the first thing, is we're going to do b over 2x minus 1 plus c over 2x minus 1 squared. Okay, because if we were to try and bring this as a common factor, okay, there could have been a 2x minus 1 somewhere in the mix. Okay, and just as a kind of proof, if we think about it, if we've got, thinking back to the question that comes up, if we've got 1 over x plus 1 over x squared, okay, your common factor there, your common denominator, sorry, could just be x squared. You multiply top and bottom by x. Okay, so you end up getting x plus 1 over x squared, and it doesn't look as though you had anything smaller than that, but you did start with something with a smaller power. So we need to include it just in case. Okay, we don't quite know. But again, as with before, we are going to multiply through by whatever the denominator is. And so this case just happens to be x minus 2, 2x minus 1 squared. Okay, so that's going to leave me with 6x squared minus 6 on the top equals a lots of 2x minus 1 squared plus, and I'm going to have x minus 2, 2x minus 1 lots of b, okay, because only one of my 2x minus 1s will cancel with the bottom bit, plus x minus 2 lots of c. Okay, so again, we're always trying to look for the easiest ones. The easiest one that I can see there is to let x equal 2. Okay, and that's going to get rid of my x minus 2 bracket. So if I stick x equals 2 in, I'm going to end up getting 2 squared is 4, 6 is 18, equals 2 times 2 is 4, minus 1 is 3, squared is 9, so 9a, plus, and then I get 0 and 0, because if I put 2 in there, I get 2 minus 2 is 0, so that whole thing goes away, and that thing goes away. And so 18 is equal to 9a, 18 over 9 is equal to a, which is equal to 2. Okay, so next thing I'm going to do is I'm going to let x equal a half. So I know kind of alluded to in the other video that we didn't do it, but we absolutely can if we want to, if we have to. So let's stick that in and see how we get on with it. So if we shove it into the left hand side, we're going to get 6 quarters minus 6 is equal to, I'm going to have 0 plus 0, and then I've got a half minus 2, so I've got minus 3 over 2 lots of c. So let's tie this down a bit. I've got 3 over 2 minus 6 equals minus 3 over 2 c. And so minus 9 equals minus 3c. Okay, again, a couple of ways you can do it. You can bring it together, or here you could multiply everything through by 2. That's going to give you 3 minus 12, which is minus 9, equals minus 3 lots of c, which is probably the easiest way to do it. So minus 9 over minus 3 is equal to c here, which is just 3. Next thing I'm going to do if all else fails, and it gets a bit confusing, because what I need to decide now is I need to decide what value I want x to be. And if I make x equal 2, I can get rid of those brackets. If I make x equal a half, I can get rid of the other bracket. But in doing so, every time I've gotten rid of the b thing in the middle, because b has both the brackets. So what I'm going to do now is, because now I know a and c, it doesn't matter what value I pick. So I'm just going to let x equal 0, and I'm going to go from there. So if x is equal to 0, on the left hand side I'm going to get minus 6 is equal 2, and so 2 lots of 0 is going to give me 0, minus 1 squared is 1, and I know my value for a is 2, so I've got 1 times 2 to start with, plus, well again I'm going for 0, so I've got minus 2 times minus 1 lot of b, and so I've got 2 lots of b, and then there at the end I've got 0 minus 2 is minus 2, so minus 2 lots of c, which is 3. Okay, so again, process here isn't difficult, but what is going to cause us mistakes, what is going to cause us to trip up, is just arithmetic. Okay, we're going to copy it down wrong, we'll lose a negative, and we'll get muddled up. Okay, so we need to make sure that we're being careful, and we take as much time, as much space as we need to be doing it. So minus 6 is equal to 2 plus 2b minus 6. Okay, tidying that up, 2 minus 6 is minus 4, take that over, becomes plus 4, so I get minus 2 is equal to 2b, so minus 2 over 2 is equal to b, which is equal to minus 1. And so what we can say there is that 6x squared minus 6 all over x minus 2, 2x minus 1 squared was equal to 2 over x minus 2 plus, well, it's minus 1, isn't it? So let's not confuse our negatives, let's just keep it as minus 1 over 2x minus 1 plus 3 over 2x minus 1 squared. Okay, and you'll find that when you're doing these, this was the term that we tend to forget. Okay, people always tend to forget that one, and sometimes it will just come out as 0. Okay, sometimes there wasn't any there, but as we looked at before, we can't rule it out, and so we need to make sure we remember to include it. And here in this case, we did still have one.